This is video 2 for our conditional probability worksheet. So I'll be going over the back of the worksheet in this video. If you have not watched video 1, go ahead and do that first so you have all the answers to the front side of the worksheet. Let's go ahead and get started. Looking at question 4, we're looking at the Venn diagram on the right-hand side. Part A says the probability of A given B. Well, let's rewrite this with our formula that we saw on the front of the worksheet. We have the probability of A and B divided by the probability of B. Remember that little upside down U is the and symbol in probability. Where it says A and B, in a Venn diagram, that's just where they overlap. So my A and B is 0.2. So I'm going to write that down as the top of my fraction. The probability of B, specifically B, is not B and not A. It's not B and the stuff on the outside. It's B, the entire circle. So the probability of B is that whole circle. Not just part of the circle, but the entire circle. So we're going to take the 0.1, add it to 0.2. Our denominator is 0.3. On the front side of this paper, it did ask us for rationalized fractions. Here, it's asking for decimals. So we're going to take 0.2, divide it by 0.3, and we're going to get the decimal 0.6 repeating. That bar on top means that that 6 goes on forever, 0.66666 over and over and over again. So now let's look at part B. Same thing, just switch the letters. Well, sure, we can do that. Probability of B and A, still going to have that same intersection, but now our denominator is the probability of A. So our intersection is still the same. It's that 0.2 that we saw earlier. A and B, B and A, same thing. What's different is our denominator. We have the probability of A. A is this entire oval. Not just the 0.3, but the 0.3 and the 0.2. We add them together, and our denominator is 0.5. We want this as a decimal, so we plug it into our calculator, and that gives us 0.4 as our final answer. Part C is a little bit different. There's this thing with an apostrophe. What is that? We haven't really seen that before. That means not. So not B. Let's rewrite question C. We have the probability of A and not B, so everything that's not B, divided by the probability of not B. So anything except B, like B just needs to get out of here, we don't want it anymore. So let's start off with our top. Probability of A and not B. So here's our probability of A. We also have not B, so we can't have any of this. What's left over? Well, what's left over is this 0.3. It's inside that circle, and it's not crossed out. So our top of our fraction is going to be 0.3. Sorry, my computer's running a little slow. Let's wait and see if it can catch up to us. And let's talk about what not B is. Not B is everything that is basically not scratched out. There it goes. So if it's everything that's not scratched out, then that also includes, I don't know if you saw earlier because it's kind of hidden in the corner, but it includes the 0.4 in the corner. So 0.4 means that it's not A and it's not B. It's not included in the actual circles of the diagram, but it is in this space. So for the denominator, we have what's not B, is everything here in A but not B, but also everything over here that's just not in anything. Add those together and we're going to get 0.7. And just so that's a little bit hard to see, I will switch colors real fast. When we divide 0.3 divided by 0.7, we're going to get approximately 0.429, making sure that we're rounding up to that 9 and we don't leave it 0.428. Well, now, what do we do if we have B given it's not A? Same sort of process, starting off with the probability that it's B and not A, divided by the probability that it's not A. Well, probability of B is this circle. Probability that it's not A means all of this is gone. It is not part of what we're looking at. The only thing that's left is the 0.1. So our top is 0.1. Our denominator is going to be anything that is not crossed off. So all of my A crossed off, but we're left with this 0.1 and that 0.4. So my denominator here is going to be 0.5. And when I do 0.1 divided by 0.5, I'm going to end up with 0.2. For question number 5, it's a little bit different. We don't see a Venn diagram. It tells us the probability of B. It tells us the probability of A given B. And it asks us, what's the probability of A and B? In order to do this, we need to set up that equation that we had earlier. So we have our probability of A given B is equal to the probability of A and B divided by the probability of B. Our unknown is the probability of A and B, so we actually want to get that by itself. We want to isolate this part here. In order to isolate it, I need to get rid of that probability of B. So I will multiply both sides by the probability of B. When I do that, this probability of B on top cancels with that probability of B on bottom, and I'm just left with the probability of A and B is equal to the probability of B times the probability of A given B. From here, just plug in the numbers it tells you. We're told the probability of B is 0.6. We're also told the probability of A given B, and I wrote over it just a little bit with that yellow, but that is 0.2. When I multiply that, we end up with 0.12 as our final answer. So let's follow that same sort of process when we're trying to solve question number 6. So question number 6 tells us that the probability of A is 0.8. It tells us the probability of B given A is 0.3. And the probability of B without A, so B not A, is the 0.16, which I see from the picture on the right-hand side. Let's go step by step. Part A says determine the probability of A and B, which is what we just did in question number 5. So in question number 5, we realized that we have to multiply our probability of B times the probability of A given B. So if we're switching it around, if it's the probability of B given A, then all we're going to do is multiply by that probability of A. So it'll be set up this way. The probability of A and B, so I'm already solving for this A and B to be by itself, is equal to the probability of A times the probability of B given A. And if you want to go through all the work we did for question 5 to double check that, you are more than welcome to. But this is the equation that we're looking at. This is what we're going to plug our numbers into. Plug in your probability of A, we have 0.8. Plug in your probability for B given A, we have 0.3. And when I simplify 0.8 times 0.3, I'm going to get 0.24. So now that I know that the probability of A and B is 0.24, I can actually write that on my Venn diagram. I can plug that in right in the middle because it's in both of them. It can go in that middle slot. So this means that the probability of B, which is the whole right circle, is 0.24 plus 0.16. So our probability of B is equal to that 0.24 we just found, because that's in both of them, added to the stuff that's only in B, which is that 0.16. The total probability of B is 0.4. Looking at part C, we're trying to determine the probability of not B and A. So when we're looking at this, we're trying to figure out, well, what's not B and A? If it's not B, then it cannot include any number from that circle. So not B, it is not inside there, but it is inside A. So it's going to end up being this missing number here. Do we have enough information to solve for that? We do, actually. We just have to look at our given information from before. We know the entirety of the probability of A is 0.8. So this whole thing here, let me change my color real fast. This whole thing here is 0.8. I know this 0.24, that's also in B, but I'm trying to get things that are not B. So I'm going to take my 0.8, I'm going to subtract my 0.24. So my probability of not B and A is equal to 0.8 minus 0.24. So my missing number there is going to end up being 0.56. On to question D, the last part of this question 6. We're told to find the probability of not A union B. So before that upside down U, that was our AND symbol. But now we have this U symbol, so it can be called union. You'll also hear OR. So it's not A or B. Now with our AND, they have to overlap. It is exclusively what they share. With this union symbol, with this U, it can be just a little bit of everything. So we're going to look at the entirety of A. We're also going to look at the entirety of B. So that A or B, that A union B, that's everything that I have circled in blue. It's not just where they intersect. But we do have this pesky little not symbol right there, that apostrophe. So that means we don't actually include anything that's in there. It's just gone, cross it out, goodbye. So we're left with everything on the outside. So we have to figure out, well, what is our number on the outside? Probabilities will always be equal to 1. And we know most of this Venn diagram. So why don't we add it up and see what we get? and how close it is to 1. So we know that we have 0.56, which is the probability of not B and A. We have 0.24, which is the probability of A and B. Then we also have the probability of not A and B, which was our 0.16. When you add all of those together, we do not equal 1. We equal 0.96. So this space out here, like this whole space out here where we had the little number in the corner in our previous examples, well, it's going to be 1 minus everything else added together. So that little number in the corner is going to be 0.4. 0.4. So everything that's not A, everything that's not B is 0.4. Therefore, for question D, the probability of not A or B is that not 0.4, but 0.04. Sorry for the mix-up. So 0.04. And so when we're given A union B, it's everything I circled in blue, but because it's not A union B, it's everything outside of that. And now we're on to our last problem, which can be a little bit harder for you guys to figure out. It takes a little bit of critical thinking. So it says, 2 events can be determined to be independent if the probability of A given B is equal to the probability of A, and the probability of B given A is equal to the probability of B. Well, let's just start off by writing that equation. I mean, we've been using it this entire video, so let's keep rolling with it. We have the probability of A given B is equal to the probability of A and B divided by the probability of B. Now, if what we're reading here is true, then I can set this whole thing also equal to the probability of A, because we have the probability of A given B is equal to the probability of A. Let's just try to get that probability of A and B by itself. Just trust me. In order to get probability of A and B by itself, I'm going to multiply by the probability of B on both sides of the equal sign. And I am going to focus just pretty exclusively on these right 2 equations here. When I multiply by the probability of B, this one on top and this one on bottom are going to cancel, and I'm going to be left with the probability of A and B, and that's just an interesting way to write the and symbol. There's nothing super special about it, is equal to the probability of A times the probability of B. And this is actually true of all independent events. So if I have flipping a coin and rolling a die, when I find those 2 probabilities, 1/2 and 1/6, I multiply them together. So this is true for independent events. We're good to go. Let's do the exact same thing, but with B given A. So I'll rewrite this as the probability of B given A is equal to the probability of B and A divided by the probability of B. So just like before, I want to make sure that I'm getting that whole thing, this B given A, equal to the probability of B. So this whole thing here, this B given A, is going to be equal to the probability of B. Oh, and if you caught me, congratulations. this denominator here is not supposed to be the probability of B. I was going on autopilot a little bit. This is supposed to be the probability of A in the denominator. So just make sure that when you have something given something, that second one is what goes on the bottom. Just testing you. From here, we want to multiply by what's in the denominator. So we're multiplying by the probability of A, multiplying by the probability of A. This probability of A will cancel with this probability of A. And what we're left with is the probability of B and A is equal to the probability of B times the probability of A, which is the definition of independent events. This has been your second video on the conditional probabilities worksheet. If you have any questions, please reach out to your teacher.